Yes, so our speaker for today is Ottone Scammacca, who is a geographer and soil scientist working at the Georesources Laboratory at University de Leuven. Research interests concern soil ecosystem services, soil contamination, land reclamation, and land planning. And today we'll be here discussing the risk assessment of mining projects at the territory level using French Guiana as a case study. Yes, so take it away.
Thank you very much, Simon. First of all, thank you very much for inviting me here to Professor First, and also for you, Simon, for arranging all the talks for the talk to take place, all the arrangements. And as you mentioned, I will present to you a part of my PhD, who I'm currently finishing at the Georesource Laboratory of the University of Lorraine, with Jan Gunsberger and Rasoul Medizadeh, which are my supervisors. And my PhD concern essentially the development of a methodology for the risk assessment of mining projects at the territory level. The French Guiana gold mining case, it's a demonstrative example for a first application of this methodology. So first of all, just to start, sorry. First of all, as you all know, mining can be the potential source of positive outcomes. We can call them positive risks or opportunities, if you may, that might be like the creation of job opportunities or wealth or economic development and growth for the territory in which they are located. However, at the same time, beside those positive outcomes, mining activities can be also the source of an important degradation of the socio-ecological spheres in which those activities take place. For instance, here you might see I think you all have seen that it's the video. I think you can see the video, I hope. It's the video of the collapse of Brumadinho dam failure in January 2019. So of course, this is one of the most catastrophic accidents that can happen in the mining sector. But yet it is important to understand that those kind of events, as you can see, exceed very importantly the perimeter of the mine site itself. For instance, I will stop this one to try to get, sorry, I don't know how to get out from this part. As you may see, this is another dam failure that took place in 2014 on the left side in British Columbia. And as you may see, those kind of outcomes, positive or negative they might be, they overcome and exceed the perimeter of the mine site itself. And they cause important alteration of the territory in which mining takes place. Therefore, mining should be considered rather as a matter of land planning than an industrial simple object alone. Indeed, when mining activities do not respect or satisfy the socio-environmental performances of the territory where they are located, you can have even some social movements, opposite movements of contestation and opposition, like in the picture on the right side, which is a social movement against a gold mining project in France, in the southwest of France. And this might lead also to halt or delays or for instance, the stop of investment, of public investment, or political constraints, or different regulatory frameworks, and a lot of factors that might that might represent an entrepreneurial risk and a cost for the mining company themselves. Which means that finally, the risks, positive or negative, they might be generated by a mining project, finally rebound positively or negatively on the mining company itself. The problem is that currently it exists a wide range of methods to assess the risk related to mining projects. However, they present some advantages and some limitations at the same time. For instance, let's imagine that let's consider a territory system through a socio-ecological approach. For example, we have a territory which is composed at the same time with a natural component, a natural sphere, and a human sphere in interaction among themselves. Let's say that we want to place different projects in this territory, different projects of different size, different nature, different processes. current mandatory risk assessment methods often focus on only on the mining project itself, which doesn't mean that they do not consider at all the external environment in which the mining project takes place, but it means that they evaluate the risk based on the mining project objectives, which is so it is anyway a project-centered approach. Most of all, those methods assess the risk on one mining project at a time, and they do not consider the potential coexistence of multiple mining projects in one same territory, and which often are of different size and different natures. At the same time, there are also other methods. For example, we can have also some assessment methods that focus on the vulnerability of the territory in which mining is taking place. Or that in this case, for example, they focus only on the territory in which mining is performed, and they consider in some cases the mining project as a black box, which can be the case, for instance, in some cases in life cycle analysis studies, in which the availability of data related to mining projects it's not so easy to access, especially because such data depend on corporate reports. In the other case, it was, for example, they currently use the impact assessment studies that are used at the scale of the project. They are usually performed by experts which are recruited directly by the mining project operator, the mining operator, sorry. So what we would like to do is to develop a methodology that managed to integrate all those aspects. I mean, the territory system, the mining projects, and their variability, and the territory in which mining is performed. It is important to underline also that this PhD started with, this project started with my PhD, so it is the first basic approach to develop the methodology. More specifically, what we would like to do is to develop, as I said, a methodology at the territory scale to take in consideration the variability of mining projects, their size, their nature, their technique used, and the coexistence of multiple mining projects in one same territory, the variability of risk natures. We can have geotechnical risks, environmental risks, social risks, political risks even, the adaptability to data, because as I said, it is a major issue. It's a major issue in any methodological development, and it can be quite critical in the mining sector, since, as I said, data can be not easily accessible. Then an important criteria and an important objective as well is the involvement of all the actors concerned by mining project, which means, for example, civil society, public authorities, or mining operators themselves, and all the persons who are concerned by those kind of activities. And finally, the comparison, the development of, we would like to integrate a scenario approach for comparing future potential scenarios for land planning strategies. And this is exactly what we would like to, what we would like to concretely do with this methodology. As I said, mining projects should be considered as a matter of land planning rather than standalone industrial objects. And therefore, the objective of the methodology is to create and develop some territorial scenarios, territorial mining scenarios, in order to analyze and compare potential strategies for mining territories, land planning strategies for mining territories. The notion of territorial mining scenario is quite important because it's exactly, this will be the center of the methodology, the center of the assessment of the methodology. So to just simplify what we mean by that, let's imagine, for example, we have a same territory, and public authorities decide to put, in one case, to imagine few potential scenarios. In one case, they decide to put 4 projects of a certain type, like big projects in one case. Another option would be like put multiple dozens of projects of a smaller scale, let's say. And another case, let's imagine a mixed scenario which involves 1 big project and 6 small projects. What we would like to know with this methodology is what is the best scenario among those 3. So this is what the methodology would like to address, the proposed methodology would like to address. And most specifically, what we want to highlight as well is not only what is the best scenario, but according to what or to whom, and based on which criteria. To understand those 2 points, I will detail those 2 points later when I will talk about the territorial objectives and the risk scenario that we would like to develop. So I will come to that part later to answer those 2 questions. Concerning the methodology, we try to follow the common process of risk assessment as is described, for example, by the International Organization for Standardization. But we try to adapt this process to the territorial objectives of the proposed methodology. So there is a first step of system definition, where we define mining and territory systems. A step of risk identification. Then we develop the territorial mining scenario and the risk scenario for each mining scenario, which the RS. And then we assess the risk for each territorial mining scenario. Finally, we have a final score for each scenario. We can compare them and we can weight those scores. And we can weight those scores, and finally we can compare them and discuss them. So just to fix few definitions, even if I think you know much more than me about this, about the different definitions of risk that exist now. When we talk about risk, we talk about the effects of uncertainties on the objectives. There are different definitions anyway of risk. Here we list just few, and we would like to capture a few common points of this definition that we consider for this methodology. So risk is considered as the effect of uncertainties on the objectives, can be also an event or an uncertain condition, the occurrence of which might have a positive or negative effect on one or several objectives of a project. Or in some other case, it can be considered even a change state event, a regime shift, and a deviation from the expected. So from those few definitions, we can first of all understand that the risk is when we talk about risk, we talk about a combination of probability and consequences. And secondly, that the risk is strictly dependent on the objectives of a project. So what does it mean? As we said, it's a deviation from the expected, a deviation from the objective that is expected for a project. So to understand the risk related to mining, what is important to understand is what is the objective of a mining project. Therefore, because of the territorial integration that you would like to enhance in this methodology, it is important. We try to underline much more the switch of a mining project from its traditional business-based view, like a mining project as a business project, to a view that consider a mining project as a development project that should meet, for example, specific performances, let's say, for example, the Sustainable Development Goals, and that should contribute to the function of the territory in which it is located. Functions that can be, for example, the delivery of ecosystem services and the supply of human well-being, the insurance of human well-being. This means that every event that might affect those functions positively or negatively, and that are related to mining activities, should be considered as a mining risk. That's why we talked about positive or negative risk earlier. As I said, we would like to apply this methodology. So I finished the part in which I was presenting you the general concepts of this methodology. We would like to apply this methodology to the case of French Guiana, which is of gold mining in French Guiana. French Guiana is an overseas French territory which is located in Southern America. And we decided to focus on this territory, first of all, as an illustration for the application of the methodology, but also because it is gold mining took has an important role in the historical and the current territorial dynamics of French Guiana. Furthermore, gold mining can take a wide range can involve a wide range of techniques and mining processes. which make it interesting to test this methodology. Also in French Guiana, recently there have been discussions about potential large-scale projects and several opposition movements that contested such activities. And so at this moment, there are a lot of debates and concerns which are related to the development of potential strategies for this mining territory, which can involve or not involve mining. So we found pertinent to try to apply the methodology to this case. And lastly, last but not least, there is French Guiana is located anyway in a very sensitive area from a human point of view for the history and the actual society, the current society that lives there, and also from ecological point of view, since it is located within the Amazon river basin. So first of all, before getting to know a bit more French Guiana, I would like just to specify a few stuff concerning gold, because gold should not be considered as, I mean, it's not a representative commodity to test a methodology, because it has a different place compared to the other commodities, since it has a strategic importance which is very relevant. Indeed, the industrial application of gold are extremely, are very limited compared to the other commodities. For instance, according to the World Gold Council in 2019, almost 50% of gold was related to jewelry production, and the rest was mainly divided between central banks and investment, while just 88% is related to technology like dentistry or application in informatics and stuff like that. At the same time, gold is easily recycled. It can be recycled, but more than 70% of its production comes from mining activities around the world. For instance, China and India are the main consumers of gold. However, China is also the first producer of gold, while India has to import. So as you can see, the main production of gold is in the hands of a few dozen countries. I mean, a bit less, come on. And which is important to understand, because this let's say this production potential is not related only to the geological presence of gold deposits, but it's also related to the juridical or the economic or technological feasibility of such activities, which means that in those countries the enhancement of the gold mining industry has been related not only to the presence of geological deposits, but also to economic strategies, political framework, which are more advantageous for mining industries or more accessible for mining industry. So we can see that the feasibility of a mining project does not depend only on the geological parameter. So this is a little point about gold that I wanted to give you. French Guiana, sorry, I come back just to this scheme. French Guiana, you have to scroll down the list very much to French Guiana gold production, especially compared to its neighbor countries. As you can see here, French Guiana is located as I said, in the Southern America, between Suriname and Brazil, and it is located in a wider geological region, which is called the Guiana Shield, which comprises a part of Venezuela, British Guiana, the old British Guiana, Suriname, which was the old Dutch Guiana, and French Guiana, a part of Colombia, and then the northern part of Brazil, with the region of Amapá. The geological importance of this shield is that it is mainly crossed by two stripes of greenstone belts, which are a formation of metamorphic rocks of sedimentary and volcanic origin. And it's mainly in those rocks that you can find gold mineralization. As you can see, I don't know if you see my arrows moving, but as you can see in French Guiana, you have two stripes, where the mining permits of exploitation and prospecting are focused. So this is just to have an overview of French Guiana and where it is located. If we zoom a bit more, we can see, so this is French Guiana with some main features. It is important to understand also that French Guiana, as I said, it's very peculiar from a socio-ecological point of view, because on one side, for instance, it has the highest demographic growth in France. In the 75, 80s, the population was around 50,000 people. Now we are almost 300,000 people, sorry. And at the same time, more than 96% of the territory is covered by the Amazon rainforest. So as you can see, I mean, there are important issues for land use at the moment in French Guiana, and important issues concerning the land planning of the region. Also, an important matter that will be also discussed later, but is that, for instance, the administrative boundaries of the region does not correspond perfectly to the ecological ones. If you think that in French Guiana, the hydrologic network is extremely dense, so river basin management is plays an important role for the planning of the territory. As you can see here on the left, the biggest river basin in French Guiana, it's transboundary and is divided between Suriname and French Guiana. And you have a different mining activity. So you have a same ecological unit divided by two countries where gold mining is taking place, but following two different regulatory frameworks. For instance, in Suriname, in French Guiana, mercury use has been forbidden in 2006, while in Suriname, no. So this leads to important issues of governance and land planning of gold mining, but also of those territories. What we would like to do, first of all, is to, as I said, to mention the steps we presented before. First of all, it is important to define the system. The definition of our system, which is the main crucial step for risk assessment purposes, was realized through multiple missions on the field, multiple mine site visits. We exchange through free interviews or public debate to a lot of people. We participated to the public debate of the Montagne d'Or project, which is which is a recently proposed gold mining project, a large-scale project in French Guiana, which has been suspended in 2018 after a public debate that we attended. So this allowed us to know and discuss with the different stakeholders, acquire some data, and try to start our first choices for the methodology. For instance, we decided to work not at the level of the whole French Guiana region, but at the level of the river basin, because as I mentioned, the water management played an important role in this region. And more specifically, we decided to focus on the Mana River Basin, which is the river basin underlined in yellow. And this choice is mainly due also because of the different exchanges with local stakeholders, which suggested us to focus on this river basin. So we try to characterize this basin through different in different ways, trying to get the human sphere, the ecological sphere, and the mining sphere of this territory system, let's say, which means, for example, to obtain data concerning the land use, the urbanized areas, the building, how they are built, where they are built, where they are concentrated, which means also to have information concerning the mining permits, how many there are, which kind, for who, to whom, about which commodity, usually it's gold, and also the ecological sphere, so rainfall data, terrain data, biodiversity, protected areas, everything we could gather. After the description of the territory system, we switch to the description of the gold mining system. As I mentioned before, in French Guiana, and usually gold mining involves a wide range of mining projects, which can have different sizes, different shapes, which can involve a different level of investment too, different processing techniques, different exploitation techniques, so it is important since The objective of this methodology is to compare territorial mining scenario for future land planning strategies. And since, as I mentioned you before, we would like to imagine some strategies in which we have a number of projects of a certain type, another number of projects of another type, and then compare the related risks. It is important for us to have a classification of all the different mining projects in order to obtain standardized model types that allow us to play with those simulation. So, for instance, gold mining depends first of all on just to cite you a few examples of the parameters that play on the gold mining project variabilities. First of all, the main parameter is the type of geological deposit. For instance, in French Guiana, you can find 5 types of gold geological deposits. Each type is exploited in a certain way, but we can have 2 main categories, let's say. A first type, which is called primary gold, which involves the type 1, 2, and 3. For example, type 1 is the real primary gold, which you find on the quartz veins, so at this primary source. Then type 2 gold, it's the one which is oxidized, so in the part of the rocks which is weathered and altered. And the type 3 is the gold, primary gold, which is residual, so that you find on the residual layers of the topsoil, of the rock. And then you have another type, which is called secondary gold, which involves type 4 and type 5, which is actually the folkloristic type of gold, let's say. For example, type 5, which is the alluvionary gold, is the gold that we can find in nuggets in the river, which is eroded and transported by water streams. While type 4, it's just nuggets of gold that are concentrated by gravity. So this is a first important criterion that distinguish the different techniques and different types of gold mining projects. Another one, for instance, is the processing techniques, which means the techniques used for the recovery of gold. Once we have extracted the rocks containing gold, we have to eliminate the rocks without economic value and concentrate the targeted commodity, in this case gold. To do that, in French Guiana, 3 main methods are used: gravimetry, cyanidation, and mercury amalgamation. The first one is the widely used, and it has a recovery rate of which is a bit among 20 and 40%, which is not very much. However, it does not require important skills, and it's not very costly. Cyanidation, no, let's switch before to mercury amalgamation. Mercury amalgamation is still used in French Guiana, and it's, as I said before, mercury was has been forbidden in 2006. Before, mercury was used by a lot of legal operators. It has a recovery rate which is extremely high because it's superior to 95%. It's not very costly, and it does not require important skills. However, as you may see, compared to gravimetry, there are different kinds of risks that are related to each processing method. Nowadays, that has been forbidden. Mercury amalgamation is still used, and it's mainly used by illegal miners. So without any control, without any safety measures that can reduce the emissions of mercury or the contamination of water streams or even of humans, because it's extremely volatile mercury. And finally, a third method is cyanidation, which is not completely used at the moment. I mean, there is one mining operator in French Guiana who developed a testing plant for cyanidation. Now they are starting to apply it at a larger level, larger scale. And cyanidation, it has an important recovery rate, but it requires very high skills and is very costly as well, because you have to build a plant. As I repeat, as you may see, there are different kinds of risks which are related to different types of mining operators. For instance, a secondary gold will be exploited in a certain way, and they will require a certain type of processing techniques, and primary gold in other ways, other processing techniques. For instance, those are a few examples of the techniques I just described. Here on the left, you have a gravimetry plant. So just this is to underline that finally those processing methods are very different also in the scale of the processing process. For instance, here you have a gravimetry plant, which is quite small, and which aims to filter, I mean, the gold nuggets by grain size, I mean the gold particles by grain size and density. Here, here you have a cyanidation plant, and it's also a small one. Actually, this one is the one that I was talking to you about in French Guiana, and it's a relatively small plant. And finally, here you can find the process of mercury and gold amalgamation. You just use the gold panning plate, and then you can do directly there. Here it is potentially an illegal artisanal miner. It's not in French Guiana because, I mean, there are no protection used for the handling of mercury. So, as I said, we use different criteria to characterize specific gold mining project types in French Guiana. The criteria that have been used are the legal status, which means the possession or not of mining permits, the type of gold deposits, as I said, between primary and secondary gold, the mining technique involved, and the processing methods, and finally the soil footprint. Just one little specification about the mining technique. I don't know if anyone known the placer mining techniques, but it involves it's a kind of surface mining, which is usually involved gold mining, and it's through the excavation of water ponds. It's done in where the water streams take place. I mean, where there are water streams, there are some ponds that are built, and the bedrock is scraped away, and then the exploitation progresses up on the upstream, following the water stream, which is deviated, and finally it results in a sequence of ponds that progresses as long as the exploitation continues. So it's a very particular type of techniques which is related to gold. So, I haven't described the project types. We have 4 main categories. One, which is ASM, which is illegal artisanal small-scale mining. Then we have 3 legal types, which is legal artisanal small-scale mining. Then medium-scale mining, which can be, as you can see, gravitary or with cyanidation. And finally, the large-scale mining type. Concerning the first one, as I said, illegal artisanal small-scale mining has been divided into primary mining and secondary mining. This is the primary mining in French Guiana. As you can see, it takes, I mean, the exploitation site is not very big, but the base camp, it's huge. There have been some base camps in French Guiana that have been found with more than 1,800 people. So as you can see here, it's very rudimentary, the equipment which is used, and sometimes they even manage to use some dynamite and other specific tools. This is secondary legal gold mining. This is what you might have. So as I mentioned, it was done on the riverbed directly. This is the legal artisanal and small-scale mining. It's the same mining technique used here, just that here it's a regulatory framework in French Guiana, which allows an exploitation which is inferior to 1 kilometer, I mean maximum 1 kilometer square. This is a legal medium-scale gold mining, which focuses mainly on primary gold. And this is in specific. This I think it's a gravitary. Yeah, it's a gravitary. It's a gravitary project. Then, as I told you, we don't dispose of pictures concerning the cyanidation medium-scale mining because it's still in development in French Guiana. And finally, legal large-scale gold mining, which are absent at the moment. As I mentioned you, there were 2 projects. First of all, the one more recent, which was Montagne d'Or, that is suspended, and another one in 2007, 2008 that has been blocked at that time for political reasons and for environmental concerns. The second step, it was risk identification. I used the same picture and the same slide as before, because finally, when we were trying to define the system, we were also trying to identify main risks related to mining projects, talking, as I mentioned, with local stakeholders such as mining companies, civil society, and public authorities. This is just a table of the main risk identified. What is important to understand is from this table is that we have negative and positive risks, and which is important to understand is just that each gold mining project type that we have defined before has a specific number of risks, a specific type of risks, which are also identified by different sources in this case. So here you have the negative consequences like cyanide spills, which of course will involve only the last two types of projects, which is medium scale with cyanidation and large scale mining, because the other one do not use cyanide processing, cyanide-based processing, and also positive risks. Of course, the list of negative risks is a bit longer than the one with positive. So after we have done the risk identification process, we arrive to an important step, which is the development of territorial mining scenarios. As I said before, the objective of the methodology is to compare different territorial mining scenarios to know which is the best one, let's say. Each mining scenario is composed of different mining projects, but what is important to know, it is according to what or whom those mining scenarios are the best one. This mining scenario is the best one, and based on which criteria. So to answer those two questions, the first one is that we built the territorial mining scenarios based on some what we call the territorial objectives, which means the objective that public authorities, for instance, or all other stakeholders want to give to a specific territorial system. For instance, let's imagine I'm a public authority. I say that for the river basin that we are studying, I would like that the mining sector create, let's say, 10,000 posts, for instance, or that a certain amount of gold is produced every year by the whole sector in this territory. The criteria used to evaluate those mining scenarios are mainly two, which is what is called RSO and RSA, which are risk scenarios. It means that we compare the territorial mining scenario based on a score which depends on their level of risk. So we develop for each territorial mining scenario two risk scenarios, which is an ordinary risk scenario and an accidental risk scenario. In the first case, the ordinary risk scenario involves all the potential consequences, potential outcome, the potential risks, sorry, that occur just because, I mean, it involves the risks whose occurrence is related just because the mining project exists. So there are certain events because their occurrence depend on the mere existence of the mining project. For instance, you have a surface mining project, for sure the mine site will involve the deforestation of a specific area, for instance. The accidental risk scenario involve, on the contrary, the risks that occur during the the abnormal functionment of the mining project. So it involves the accidental events that are considered outside the normal functioning of the project. For instance, a tailings dam failure is not a normal event that a mining project would have, or an explosion, or those kind of events. For instance, just to specify a bit more of the territorial objectives, let's try to apply that to the French Guiana gold mining case. First of all, this is what we would like to obtain at the end. So we have the three orange boxes represent the territorial mining scenario. As I said, for each scenario, territorial mining scenario, there are two risk scenarios which are assessed based on their global level of risks. So just to try to see how we can apply that to the French Guiana case, let's say, for instance, that public authorities decide to take individually three objectives. On one side, we want a gold mining sector that globally in Mana River Basin produce at maximum of 5,000 kilo of gold per year. Another objective separated from the first one, which concern the creation of 3,000 jobs. And finally, another objective that, for instance, we want a mining sector that does not exceed a consumed surface of 2,000 hectares. So as you can see, for each objective, a range of scenarios are created that can meet those objectives, and for each mining scenario, the corresponding number of mining projects, types and number of mining projects are located to in the territory system we chose. For instance, for this demonstrative application, I will show you just concerning the first objective. As I said, for an annual gold production of 5,000 kilo of gold per year, as you can see here, we have a first scenario, which is a TMSA, in which we, for example, we know that just one large-scale mining project can meet the objective of 5,000 annual gold production. Another scenario B, where 6 medium-scale mining with cyanidation are located fictionally. Another one which involves 33 artisanal small-scale mining. So for the production of one large scale, we have 33 artisanal small-scale mining projects. Finally, a scenario D, which is a mixed scenario, let's say, because we mix artisanal small-scale projects with gravitary medium-scale and cyanide-based medium-scale projects. And finally, an illegal scenario, which involves no legal activity, but only illegal mining. And to produce that same amount of gold, we would need 758 illegal projects. So what we are going to do is to take the mining project type as defined before in the multi-criteria classification. Let's say that it is important to say that each gold mining project type is represented by a series of standardized values, a range of values that represent their specificities. For instance, I don't know how many people work in that type of mining project, or which is the height of the dam, which is, for instance, the operation, how much operational cost it involves this type of gold mining projects, or I don't know, which are the gold recovery methods used, how much cyanide is needed for this type, or how big it's the pit for the exploitation, all those kind of specificities. So sorry. So we take those models, let's say those typologies, and we locate fictionally in the territory system that we chose. This localization, of course, is fictional, but at the same time, it has to be based on different criteria. In this case, we use the three main criteria, which are the geological suitability, juridical suitability, and the geotechnical suitability. In the first case, it depends on the presence or absence of primary or secondary gold mining deposits. The juridical suitability is represented by the departmental mining plan, which is a French Guiana regulatory framework, which states where mining is authorized or forbidden. And finally, a geotechnical suitability, which concerns the technical feasibility of the project. And few authors suggest that usually this, for instance, the slope should not be superior to 15%. Yeah, so it should be unfavorable here, sorry. So here we create a suitability map for the localization of the projects that is done through GIS-based algorithms and functions. Once we have those areas, which are the big gray areas, are the one for primary gold mining, and the green one, which you cannot see so well, are the one for secondary gold mining. So what we do, as I said before, for each mining scenario that we developed before, we localize the corresponding mining project or mining projects. For instance, in the first scenario, we have one large-scale gold mining project. The second one, we have 6 medium-scale with sanidation, etc., etc. Until here, in the last one, we have 758 legal gold miners. Once we have localized, and so let's say to have, once we have concretely our scenarios, because each one represents a potential scenario, we developed for each one of them 2 risk scenarios, as I said before. Of course, those 2 risk scenarios should have to be the same for each mining scenario. And we have developed them based on the identified risks. So based on a database of identified risks that we have developed through the first year, even if it's not exhaustive, in French Guiana, talking with local stakeholders, but also through a database of historical accidents in the mining sector. As I said before, we have one scenario, which is the RSO, the ordinary risk scenario, and the other one is the accidental risk scenario, which are related respectively to the ordinary or the accidental functioning of the mining project. Concerning the ordinary risk scenario, but we decide just to list a few consequences that would be considered for this demonstrative application, just as a test. So for instance, we decide to choose 4 positive consequences to assess and 1 negative consequence: raw material supply, direct job opportunities, expansion of social infrastructure, support of local education, and finally landscape degradation. Concerning the accidental risk scenario, that was quite a bit more complicated compared to the first one, and we decided to focus on the tailings dam failure. That was explained mainly because first, it was a major concern by local population during the public debate in French Guiana, and also because it's interesting to test an event which has an important specialized footprint on a methodology which is based also on GIS tools. So for this tailings dam failure, so we decided to focus on this type of failure. Just to remember what is a tailing dams. A tailing dams, it's an embankment used by mining companies to store and settle water and tailings. So the tailings are the wastes from the processing of the mining operations. So you have a first part, which is the embankment here. I really hope that you see the arrow. I don't know, but I hope. Then the foundation soil and the effluent, which is composed of the supernatant here in the surface and the sediments. This, of course, is a simplified scheme. There will be way more detail, way more parameters to detail to assess to have a full vision of what is a tailings dam. What is important also to know is that, for instance, here on the right, you can see that the more the exploitation continue and the higher are the amounts of waste, of processing waste, well, the higher the tailing dam should be raised. So those kind of elevation methods are commonly used by mining operators. There are 3 main types that are used, which is the center line, the downstream, and the upstream. The upstream is currently the most used, since it's the most economic one, but it's also the most dangerous one. For instance, in Brumadinho or even in San Marco 4 years earlier, but the dam that collapsed were elevated through an upstream method. And in San Marco, this criterion played an important role on the failure too. So concerning the not pleasant subject of the mining accident, and especially the tailings dam failures in the mining sector. As I told you, we developed we are developing actually a database of historical accident in the mining sector. An important role is played by the tailings dam failure, also because they are widely reported and there are a lot of database that exist. And as you can see here, for instance, we have between 1850 and 2020, we have a great number of accidents, with a peak in the 60s, which is due especially to seismic events in Southern America, which led to the failure of several dams in Chile and Peru, for instance. And finally, you can see that the intensity of accidents seems to be higher during the last 50 years, which is especially due to the fact that those accidents are also more reported compared to before. Of course, there is an intensification in the occurrence, but it's intensification also on the mediatization of these events, which is, of course, normal and facilitated by the information sharing processes that we have today. But just, for instance, since the beginning of 2020, we have, according to the database of WISE Uranium, which is accessible to everyone, I think we have already 6 or 7 events of tailing dams failure. So just the major one also. So that's why also we decided to focus on this failure, on this risk event. The main important mechanism of dam failure are, as described by a recent report of the United Nations for the Environmental Protection, is those are the main mechanism, failure mechanisms. The one which has the higher occurrence, and which is also the most frequent recently, is the overtopping. Then you have slope instability, seismic instability, structural failure, foundation failure, external erosion, seepage, and mining subsidence. So because of the importance of overtopping, we decide to use this mechanism for our scenario. So we say that in our accidental risk scenario, we have a tailings dam failure by overtopping. We went we realized some field visits in order to observe and to study a bit more the mining dams in French Guiana. As you can see, also different mining projects involve different mining dams. For instance, on the right, you can see the kind of mining dams used in primary gold exploitations. This is a medium-scale mining dam with the draining devices. This is the downstream part. And on the left, you can see the mining dam systems in secondary gold mining. As I mentioned before, secondary gold mining is constituted with a sequence of ponds that are delimited by small dikes rather than dams, earth-built dikes. So for sure, the tailings dam failure will have different results according to the type of project and the size of the projects, of course. For this scenario, we selected a range of 18 events, 5 of which at the scale of the project, of the mining project. The one in red are highlighted just because they still haven't been assessed at the moment. So we try to create a scenario which involved different kind of consequences of different natures, for instance, social consequences or environmental consequences, but also technical consequences related to the mining project. Here we decided, just to facilitate the lecture of those consequences, we decided to use a kind of bow tie diagram where we have the initial event, which is the dam failure by overtopping, in the middle. On the left, we have a fault tree, a kind of fault tree, which represents the probability of occurrence, the events that the triggering factors that need to be considered for a probabilistic assessment of this failure. And on the right, side, the event tree, which represent the consequences of the failure once the overtopping occurs. It is important to highlight here too that the probabilistic dimension has not been integrated in this methodology at the moment. As I told you, it is still in development, so we try to integrate it only through a qualitative approach. So this is the important stuff I wanted to tell you. Now, I know that we don't have so much time, so I mean, the part of the assessment, I would like just to show you what we did. The most important for me was to present you what we want to do and where, and to highlight the importance of the territorial mining scenarios for our methodology. So this just to quickly highlight how we evaluated the risk scenario. For the ordinary risk scenario, we had our event. We have our selected events, as I showed you. For each event, we chose an indicator that, and then we assess the indicator. We define some risk thresholds. We quantify the indicator based on these thresholds, and we convert that in class from 1 to 5 according to the intensity of the consequences. Once we have calculated that based on the available data, we have a total positive score. Here you can see, then a negative score, which is converted, and then the aggregation of those two scores and a probability of occurrence, which is always equal to 1. As I mentioned, in the ordinary risk scenario, it is important to have, I mean, we said that it depends on the mere existence of the mining project, so those events are certain. If the mining project is there, this event will occur as well. So we obtain a global RSO score, which places the legal mining at the last place and the large-scale mining at the first one, which is mainly due to the soil footprint, which is inferior in the first scenario compared to the other ones. For the risk scenario assessment, it has been a bit more complicated because what we wanted to do, it was to combine 3 main criteria. First of all, the impacted area from the accident. In this case, for instance, it is the flood area. Then the vulnerability of the territory, which means the socio-ecological susceptibility of the components of the territory to be damaged by this event. And finally, the probability, which, as I said, was given through a range of values through a qualitative and expert-based way. So first of all, to evaluate the impacted area, we tried, because it's a process that requires important amount of data, hydrological and hydraulic data. We combined 2 methods, one developed by the researchers at the Columbia University, which is the first one, which is very raw, but at least it allows to have, through empirical relationships and equations, it allows to have the released volume and the runout distance of the tailings once the failure occurs. And it allows us to have a maximum flood perimeter. Within this flood perimeter, we developed a second methodology through some tools, specialized tools in GIS tools that allows us to have flow accumulation areas and the main preferential drain flows of the tailings. So we combine those two methods that I will not detail here, and we obtain a specific flooded area for each scenario. For instance, this is the examples for the first scenario, which involves one large-scale mining project, and as you can see, this is the potential flooded area. In the TMSB, we have six medium-scale mining projects, and their corresponding flood area. And here in the TMSC, we have 33 artisanal small-scale mining projects. Of course, in this case, as you can see, the resolution is much lower compared to the first case because of the different size of the project. So here too, we have our events, our consequences. For each one of them, we decide to, we selected an indicator for their assessment. And for the assessment of the socio-ecological vulnerability of the territory, as I mentioned, we we assess the vulnerability and we obtain few maps for each indicator. For instance, we have the first one concern the vulnerability related to the drinkable water. In the second one, we have biodiversity, if I don't mistake. Then we have this is wood production. Then we have a soil erosion or soil fertility, etc., etc. Once we have all these multiple maps, we aggregate them to obtain an overall socio-ecological vulnerability map that we will cross after with the impacted area zone that I showed you before. In this case, we will obtain, for instance, this is the LSM, the first scenario assessment. We obtain a consequence map. This is with or without the probability that has been integrated through different assumptions. But as I told you before, the integration of probability in this methodology at the moment is still very raw. And so in this way, we can obtain some maps that show the total consequence level of the mining project according to this accidental scenario. Once we have that, we try to, I don't want you to read all these images. The important thing to understand from that is just that we try to arrive to the final global score through different steps that results from the aggregation of the steps below, let's say. So once we arrive to the global RSO score and the global RSA score for each scenario, we proceed to the weighting to the development of weighting coefficients that has been done in French Guiana through the development of questionnaires, a questionnaire survey that has been distributed to local stakeholders in order to capture the relative importance of each responded to a potential territorial asset that would have been impacted by the mining project. This allowed to analyze the data, the responses, and to develop weighting coefficients. For instance, here we have weighting coefficients related to civil societies, and here weighting coefficients relating to the public administration. And once we obtain those weighting coefficients, we could integrate them to the risk scores. So here, what is important to obtain, you have all the steps of the assessment, the weighting, the probability integration, the conversion, etc., etc. And what is important to have is to consider is this final line in which we have the global weighted score for each territorial mining scenario. For instance, for how we did the methodology, based on our criterion and our thresholds, our methodologies, our everything, our decisions and our assumptions. In this case, and on the data used, in this case, the worst scenario is related to the illegal territorial mining scenario, and the best scenario is the scenario which includes 6 medium-scale projects with sanitization. Of course, this methodology does not lead to taking a decision, but can be seen as a tool to be improved, because this is still the first steps of the methodology, to be improved, to be integrated, and that can serve as a support for decision making for land planning. Just a few words to conclude my presentation. I showed you this tool that is still incomplete, but at least, I mean, it's still to be ameliorated on different aspects. First of all, the project type classification has been anyway an essential step that needs to be achieved for the development of potential scenarios for land planning decision-making perspectives. However, it is important to address a few issues concerning the normalization of those mining project types. As I said, for instance, the flood area of one artisanal gold mining project cannot be comparable to the one of one large-scale mining project. And then other issues should be addressed. For instance, the case of illegal gold mining, it cannot be considered as a mining project since it is rather a social phenomenon where the notion of project is not well considered. We never know where it starts one illegal project and it finishes another one. So it is important that the methodology let's say, consider much more considerably, let's say that it has to integrate much more those kind of specificities. Then, of course, the results of this methodology concern French Guiana, but it is important that the methodology can be the structural grounding of the methodology can be adapted to other cases. However, the results will change for sure. That's of course. For instance, concerning the classification, if you would have done the same classification in Suriname, we should have followed the same methodology to build the classification, but the results would be completely different. Even the criteria used, for instance, in Suriname, mercury cannot be used as a criterion distinguishing legal from illegal mining. Or there are other kind of gold mining projects, such as gold dredging, which create a lot of sediments, so it has also specific risks. So each territory and each mining systems represent a case study, but what it is important is that the methodology should prove its flexibility and its adaptability to other cases. Also, the development of territorial mining scenarios and risk scenarios has an important influence on the final scores. So it is fundamental that these steps integrate in a much more structured way the local stakeholders. Finally, concerning the estimation of the risk, even if I haven't detailed that so much in this presentation, it's important that there are no specific methodologies for those kind of purposes at the moment in French Guiana. So it is important that the assessment follow specific methodology which has been tested, validated, and proved by experts in every different scientific field and area. For instance, concerning the flood area, it would be important to gather more data to perform more accurate assessments, such as for instance, using models like HEC, RAS, which are widely used for flood estimation, or even, for instance, the probability assessment should be more accurate. The integration of safety measures is fundamental because it depends on the project type, and it has a major role into the reducing the probability of occurrence or the consequences of a risk event. And finally, also the weighting coefficients should be ameliorated in order to integrate as much as possible all the different stakeholders. For instance, we didn't manage to integrate the mining operators stakeholders category group because just one person responded to the questionnaire. Concerning the methodology proposed, so as I mentioned before, we have advantages and limits of this structural grounding, but anyway, it represents an important first step that will lead to a more structured methodology. The ecosystem services approach can be very important for a risk assessment that is at the territory level, as we mentioned at the beginning of this presentation. Since it can allow to value at the same time social and environmental risks related to mining projects. Then the methodology can be adapted to other commodities, and so other mining systems and other territories, even if the results and the criteria used will be different. An important limiting factor, which is actually the limiting factor in every case, it's the availability of data. What is important anyway is that the methodology is adaptable to the available data. And so new important let's say important advancements should be done towards the gathering of much more data, for instance, in French Guiana. And finally, yeah, the stakeholder integration that I mentioned before. And finally, there are some just special issues that should be addressed. For instance, the localization of the mining scenario has an enormous influence on the risk scenarios, on the results. So it should be performed through much more recognized and unanimous methodologies. Territory-based, let's say that the territory ratio of the methodology sometimes is in conflict when we have to assess the consequences of the project scale, which we still haven't managed to do at the moment. And finally, what I mentioned before, the transboundary nature of some risks when they exceed from the territorial system which is considered. For example, I mentioned before the risk concerning Suriname and French Guiana. As a future perspective, we would like to improve this methodology to support land planning of mining territories. For instance, we compared that with the strength, weaknesses, opportunities and threats analysis, the SWOT analysis. Then it would be important to integrate from a government's point of view the recent tool of social license to operate in responsible mining in order to ameliorate as I say, the rendering of the methodology, which would be also done through the integration of decision-making tools like Electra, like AHP or other tools. As I mentioned before, the role of safety measures should be integrated as faster as possible. We couldn't because we don't have enough information, enough data about that. And particularly, it is important also that uncertainty and sensitivity should be quantified, especially if we develop a methodology which is available which is adaptable to the available data. And finally, we would like to create, it's a project we had last year to develop anatomized GIS-based tool in order to be able to perform the assessment directly on GIS tools and with a few lines of code. So I hope I have not been too much long. Yeah, I have. And I hope the subject has interested you, and therefore I thank you very much for the attention you had during this speech. And I'm open to any questions if you may have.
Yes, thank you, Ottone. Yeah, so we'll be opening up for questions now. If you have a question, please click the raise hand option. To raise your hand, just go into the participants menu on the bottom of your screen and click raise hand on the right. Otherwise, then I'll call on you to unmute your mic. Otherwise, if you would rather not ask a question personally, you can type it in the chat. I'll read it out for you. Yeah, so first question, we have Adolphus. Like to go ahead?
Yeah. Thank you, Simon. Good afternoon, Ottone. First of all, thank you so much for your insightful presentation of your PhD project, and it's really in-depth, and I'm personally quite interested in all this mining, the risk related to mining activities myself. And so basically my question to you is with regards to how you actually did your risk assessment. You actually had this like event tree and a sort of like a fault tree thing. Could we go to that slide where we did the risk analysis? Yeah, thank you.
Yeah, of course. You mean the first slide concerning the accidental assessment or the ordinary one?
Oh, the one that has the event tree.
Ah, yeah, of course.
Yeah, this one. Okay, so you had this this clinical initial central event. So I mean, this fault tree and event tree. Just like to ask, right? But you, I mean, you're really approaching the end of a PhD, but I would like to ask if you are by any means like interested in sort of like extending this fault tree and event tree towards the use of Bayesian networks or Cradle networks to do your risk analysis. Cradle networks especially useful because it can represent all the probability in terms of bounds, and that would probably give you like the confidence and the uncertainty with regards to your estimation of the risk associated with the various events.
Yeah. Actually, thank you very much for your questions. Yeah, indeed, we explored those kind of tools to assess the event tree. Actually, we did some researches about the Bayesian application in this case. First of all, just to underline that the event tree that we have here, it's just the selection of few events that we decided to do. We could expand it until I don't know. We could add 100 other events. Just do on 5 or 3, whatever. Depends on the data and depends also on the choices we have.
Yeah.
In this case, it was a demonstrative application. With this, we thought about the Bayesian network to be integrated in the methodology. However, we didn't have enough data to include that currently in the methodology. Of course, it's a potential perspective for the methodology that is absolutely open to that. But at our stage, we were not able to perform it. At the same time, for instance, the bow tie here used, it's only used for the visual advantages of the diagram, because
Right.
usually the bow tie, as well, as you know better than me, it's used for the directly even for the assessment of the event tree in some cases, you know. So in this case, it was really just used as a merely diagram for presenting and the events chosen for the accidental scenario. And the tool to detail this assessment were thought, but not possible to use, unfortunately, at the time, because of data availability problems.
Right, understood. Yeah, but thank you so much for your clarifications and great presentation today.
Thank you very much. Thank you very much for the questions and for the attention during the presentation.
Thank you.
Okay, next question from Carolina.
Hey. Hello, hi, Tony.
Hi.
Thanks for your presentation. I loved it. I'm a Brazilian, so I'm very passionate about this topic. As you know, Brumadinho and Samarco accidents happened here in Brazil.
Yeah.
So all Brazilians are very passionate about this topic and angry.
Yeah.
So I have some comments and questions, but I will start from the same as Adolfo's. I like this slide because that's exactly what I'm doing in my research too. I'm a final year PhD student as you, but I'm from the oil and gas industry. I'm using bow tie, and I'm quantifying bow tie in my research exactly with Credo network, as Adolfo said. Because I have tried to use Bayesian network to integrate this bow tie, but as you said, I didn't have all the data. So to allow missing data in some combinations, I'm using Credo network. So we can talk after the meeting if you want for me to show you how I did that.
With pleasure.
I'm sending the paper to be evaluated today by coincidence to the co-authors, but I can discuss. Yeah, I think the Risk Institute can help you a lot in this issue. They helped me. I didn't know anything about quantification. I'm from the regulator here in Brazil, oil and gas. I didn't know anything about quantification. They helped me a lot.
Okay.
The comments are, yeah, as I told you before, I'm Brazilian, so I'm very passionate about that. You said at the end of the slide that it can be applied to other mining. So our concern here is iron, especially, although we have gold mining too. And I really enjoy the approach about accounting for the illegal sites as well. That's so interesting, because we are, especially regulators, we are always more concerned about the legal ones, because we say, okay, the illegal ones, we just have to close them because we can't enforce anything. But we have to understand how the illegal ones work and do the risk assessment and do the integration. So I understand your main question, research question about integrating and aggregating those risks. It's very interesting.
Thank you. Sorry.
Yeah, the question now. What's the biggest problem about illegal? I know it's a supporting tool. You're not supposed to answer regulatory questions, but just to support them. But I see, at least here in Brazil, the biggest problem about the illegal ones is that the government wanted to turn them into legal, but they are inside a native protected area for native people that we call indigenous people. So there is this question about turning into legal or closing it. What's the main question in French Guiana, if you know it?
Yeah, actually, I'm happy you focus also on the illegal problem, because it's an important specificity which is not peculiar to all mining projects, gold, gems, and other bauxite in some cases, but it's very specific also to gold mining, especially in Brazil, as you mentioned. And indeed, in French Guiana, the illegal mining is producing 10 times more than legal mining, actually, because the legal mining sector is not very developed, and the illegal miners come across from the Amapá and from Suriname, especially because let's not forget that French Guiana, as part of France, is part of the European Union. So there are a lot of migratory flows that are related to illegal gold mining towards French Guiana. Actually, the problem, the socio-ecological degradation of illegal gold mining affects French Guiana also in the areas of indigenous people, because in French Guiana there are 6 main indigenous communities that still live in the forest, or even among some urbanized areas. And especially in the southern part of French Guiana, which is the closer one to Brazil, to the Brazilian frontier, there is a lot of illegal gold mining activity. Actually, at the moment in French Guiana, they are not at all in thinking about the formalization of those activities. They are fighting them through the army. There is a specific military operation which is called Operation RP. Before it was called Operation Anaconda, and before I don't remember, but anyway, they changed names a lot of times, and at the moment there is this operation which aims to reduce as much as possible the illegal mining activity. The problem is that often those people, I mean, work there as it's a substantial, I mean, it's a subsistence activity for them. So they come back, or because I mean, I think it's very out of control. On one side, military actions are reducing the presence of illegal miners, but at the same time, it's an activity that you cannot actually erase, because it is pushed by social conditions. I'm sorry, economic conditions. So you will not erase this phenomenon. Personally, actually, I'm very interested in the process of formalization that they're doing in some countries in South Africa. In Africa, sorry, like South Africa, like Ghana, like Burkina Faso, if I don't remember. There is a convention that has been signed in Cameroon, which is called the Yaoundé Convention, which talks about this matter, if you're interested. And I don't know if it's the best way, but I think it's an interesting way to explore, rather than just fighting the illegal mining sector. It is important. It is interesting to explore the process of formalization on one side, but also to analyze more the circuits of illegal trafficking of gold, of illegal gold. There is a researcher, a Dutch researcher, which has published a lot about that. If you want, I can share it to you, the paper, if you're interested.
And just to finish, I would like to congratulate that you just aggregated the HIV problem as well. The idea of putting health issues in the risk assessment. There was a slide that you showed HIV, malaria problems.
Yes, it was that. This?
No, another next one.
Maybe here. Here.
It was one with tables. There were tables.
Very good to see. This one, maybe, no, I don't think so.
I took a photo.
Yeah, malaria. Actually, the one with malaria, I think, is that one, because malaria has been used as an indicator for health-related impacts here. Voilà. You can see here.
I have the number of the slide 58.
58. Okay. Okay. Yeah. Wait. 58. Yeah. Sorry. Okay. Here. Oh, sorry.
So you integrated the health issues in the risk as well. How did you?
Yeah, of course. Yeah, of course, it is an matter.
Yeah, it's an off course that I'm quite astonished. I think people in Brazil don't
Yeah,
they should.
I'm astonished of
Yeah,
your
yeah.
astonishment, actually.
Yeah, especially in those mining and oil and gas industry. They are, people in Brazil know that in those areas that lots of workers that are men, we know there are lots of prostitution, including with minors, and the regulators don't look at that. I'm feeling guilty after I saw your matrix, your risk matrix, because we know that those things happen and we do nothing. So, and HIV problems with minors, with girls, there are still minors. Yeah,
Yeah.
that's a beautiful, that's a big inspiration. Thank you.
Thank
That's
you.
it. Sorry, I
No,
talked
no,
too much.
no. Me, I just took 1 hour and a half, and I'm still talking. So no, you don't talk too much. Don't worry. No, but thank you.
Thank you very much.
Thank to you. And actually, here, as you can see, also the table shows how much those events are reported. For instance, here you have a lot of reports concerning French Guiana, concerning illegal gold mining projects, and some artisanal legal, but you don't have any information almost about large-scale projects about that. On one side, because maybe there are not, or maybe because they are not reported. You know what I mean?
Mm-hmm. Yeah, I know. Okay. Okay. Thank you. Beautiful.
Thank you. Yeah, I have a question. I just want to circle back to that question of, I suppose, risk to indigenous populations. And I know that, again, looking at Brazil as a case study, the diminishment or reduction of environmental protections encourages illegal exploitation like mining, which generates environmental hazards like fires, and also increases the trespassing and deaths of indigenous people by legal exploiters and miners. And that's, to me, like a risk presented by mining. But is that something that could be considered within this approach? Or is it something outside of it?
You mean the fires in the forest? You mean?
Well, yeah. So I was thinking. So the two scenarios you have presented were the tailings failure and the, I suppose, business as usual disruption to landscape degradation.
Yeah, actually, yeah.
But I was also wondering that, especially considering the large amount of legal activity, would the conflict and deaths of indigenous people due to kind of their operations, and also additional environmental concerns like wildfires, could that fit into the risk system at all?
Yeah, I think wildfires would be, for instance, could be used as an indicator in some specific areas where it happens, or when they are caused by illegal mining, for instance, could be an indicator for landscape degradation, could be a risk themselves to be quantified as well. Yeah, it can be actually very integrated if it's related to mining project, of course, if it's caused by mining projects. If it's caused by other activities, the methodology could adapt and, for instance, create scenarios in which mining projects are included in a strategy that includes also other type of activities, for instance, agriculture or stuff like that, which concerning the wildfire problem plays an important role. Agriculture to play an important role in that. Concerning the social conflict, actually, yeah, it's something we would have liked to do a bit deeper. Unfortunately, the problem is that for those kind of risks, social risks are very difficult to assess because sometimes you don't have enough data, you have just qualitative data, you don't know how to assess them, you don't have indicators, you know what I mean? So it is absolutely something that we could, and actually we must integrate to the methodology, the question of social conflicts with indigenous people, but it is important to understand how. There are a few papers now that have been releasing during the last decade that concern development of indicators for social risks related to mining industry, for instance.
Sure. One thing that kind of just pops in my head then as well, but relates to that, or tangentially though, is the idea of like compound factors, such as, I mean, this is a response scenario I'm thinking of, but there's probably analogs you can do prior to that, where, for example, in California at the moment, the mixture of pandemic, the COVID pandemic, and the kind of wildfires there has disrupted their emergency response, just because they use a lot of prison populations to fight the fires, and because there's a high infection rate in those prisons, their response to wildfire mitigation has diminished. And I was wondering about that's kind of response-based.
Yeah.
Are those compound risks also able to be integrated in well, perhaps? Or is it already? I might have missed it.
I can say about the question of human response, it's a key matter that should be integrated. As I said at the last during the last slides, for me this kind of this parameter is for me it corresponds to one of the safety measures, proactive or reactive, that could be used for reduce the possibility of occurrence, probability of occurrence of a risk, or to reduce the potential consequences once the risk occurred. So I think the human factor, in this case, human factor, should be and could be integrated. I don't know how, because we couldn't do that in the methodology because we don't have enough data concerning the safety measures. But I think personally, if I have to criticize the methodology I just proposed, one of the main limiting factor of the application of it now is that we haven't managed to integrate at the moment, because of a problem of data, as I mentioned before, the role of safety measures, because they play an important role in the risk management as well, of course, and they depend on the project type. For instance, we can say, let's say in the tailings dam failure. Of course, the consequences of tailings dam failure of I don't know, let's say BHP. No, sorry, or Rio Tinto project would be huge if there is a tailings dam failure. However, if there is a tailings dam failure in an artisanal mining project, the consequences are important, but nothing comparable to the Rio Tinto project, let's say. Yeah, I've been saying Rio Tinto as an example. I hope there is nobody who is with the Rio Tinto there. I mean, just an example, just to imagine a large-scale project. The stuff is that, of course, at the same time, a large-scale mining operator has much more skills, competences, and even money and investment to implement measures that reduce the probability of occurrence of those kind of events. You know what I mean? So it is important to quantify, not just qualify and identify, but to quantify the level of safety measure in each project type, and which requires enormous amount of corporate data. So, but it is fundamental, and it should be considered by the methodology as the human response. For me, it's part of a reactive measure, a reactive safety measure, and it plays an important role also in flood management, as you know.
Sure. Thanks for that. We've got a few more questions coming through.
Thank you.
Scott, do you want to ask a question?
Sure. Thanks. Ottone, on slide 78, you were talking about how overtopping was the most common mode of failure. Was that right?
Yeah.
But of course, it wasn't the most common.
Here.
The most common was unknown.
Yeah.
Do we have any idea what's in the unknown, or is that why we call it unknown, that we don't know?
No, yeah, you're right. And actually, it's a big fault on me because I neither mentioned the unknown before. I passed through this slide without mentioning the unknown causes. And actually, yeah, no, we still don't know what can be. The problem is that in some cases, even in fact, depends also on how the failure can be a mix of different mechanisms that happened at different times. And therefore, in some cases, reports don't know which was the main event, so they put in unknown. In other cases, for instance, let's say from some countries or less transparent realities, let's say, you know that there happened a dam failure, but you don't have any information by the mining company. So in some cases, it's really unknown.
I see. So it's almost surely one of the listed ones, though. Is that right? I mean, you don't list terrorism or sabotage.
In some cases, it can be even here, actually. Yeah.
So there might be mechanisms that aren't in other columns. Is that right?
No. It should, if they exist, they should be in the unknown. Oh, I think also it's done because, for instance, this report of the United Nations has been focusing on the geotechnical failure, mechanism of failure. You know.
Yeah.
But it happened actually that it was for transport, for espionage, for terrorism, as you said, also for industry. I don't know how it's called in English, but you know, somebody go there and I don't know how it's called.
In French.
I don't know how to say in French either, I think. But even in Italian, I don't know how to say. Yeah? So.
There is a famous case in Italy that was sometimes they don't know because they didn't investigate. There is a tailing dam failure in Italy that my supervisor thought it was a tsunami. People told him when he was a child that it was a tsunami, and in fact was a tailing dam collapse. So maybe it was just not investigated.
Yeah, in some cases it can be that. This is the failure that happened in the years and years ago in Italy, in the northern part, and there were some mistakes of corruption and construction that has been unveiled only a few years ago, for instance, in some cases. So yeah, for sure, the transparency issue plays a key role in those kind of in the mediatization and report of those kind of events.
I have a couple other questions, if I may. Round about slide 89, or maybe the ones after it, you were talking about the vulnerability matrix. You constructed these, maybe the ones after that, when we were talking about the socio-ecological maps that come out.
Here?
Yeah.
Here.
There, yeah. My question is, do you trust these maps? I mean, are these maps that you could use for planning, or are they really just a way for you to integrate the impacts because they're distributed over space or geographical area? Do you trust the maps, or are they really just pointers?
No, I trust the maps because the maps are the result of the quantification of each indicator. To quantify each indicator, actually, there are not at the moment specific methodology with the available data we had. So for each indicator, we ourselves developed a specific methodology for the assessment of that indicator based on the data we had, and then specialize it.
Okay.
So I trust that. Of course, in some cases, the quantification is expert-based, in some cases. So it means that it has to be revised.
It needs what?
In some cases could be revised. For instance, here, the RSA number 13 that you have here, on the left side and down here below. This is the soil map, for instance, that I did also through a huge bibliographic review of data concerning soil resources in French Guiana that dated from the 60s, because there were not specific data more recent in French Guiana, because there were not access to field measures there, you know. So I think on one side you can improve of course you can improve the results if you can improve also the background data. And at the moment, unfortunately, concerning soil, there is recently one map that has been published, but recently, like a few months ago. No, still hasn't been published, I think, by a local office in French Guiana concerning soil resources. But those maps are based on real assessed indicator there anyway.
Okay, so they're more than just tools. They're research products.
In a certain way, yeah, because finally, for the development of the methodology, we had to produce a lot of let's say, of layers that should have been mixed up to have final results, you know. So yeah, in a certain way, it's the result of our research.
Okay, so am I? You had like over 100 slides, and it went by surprisingly fast. So I may have misunderstood utterly. But is it the case that between slide 58 and this slide 95, you have taken those? I think you said there were 60. So there's health, there's ecology, there's agro, there's social disruption. There are these 60 measures, and you're integrating all those into a single scale. Is that what you're doing?
60 measures. Wait, what was the 58? It was, sorry,
It was the one that Carolyn.
Ah, yeah, okay. So this was just, this one was just a little bit database and a kind of bibliographic review based on also on our field trips to underline that, that for each gold mining project type, we have different and specific mining risk related to that.
But it's the case that you've got multivariate impacts, right? Multivariate, many different ways to go wrong, many different kinds of impacts that you have, and they're different in different spaces, different places and times, and maybe for different mines and so forth. And you do integrate them, right? You combine them into a single scale. Is that right or no?
From that slide, that table that is in 58, we select a scenario. This is a part of 18 events, for instance. The maximum are 18 events, and we assess them through some indicators, and then we obtained 18 maps like that. And we finally, of course, we went from a quantitative assessment in some cases, or in some other cases in qualitative assessment, to a semi-quantitative aggregation, let's say.
Okay, so
in 5 classes. So yes, we lost some information. Yeah.
Well, or you could say you integrated it. I mean,
yeah.
You mentioned that it's scenario based, so it could be that there are many maps for a given geographical area, I suppose. But you are trying to aggregate the different variables, right?
Yes.
Okay. So I'm sorry, I just wanted to make that clear.
No, yes, I'm sorry, because I know there were a lot of information, and I hope that was not too much. And then also the assessment part, I skip relatively quickly because I saw the time, so I didn't want to.
Sure, and there are lots of different ways to do it, of course.
Yeah.
And I wouldn't worry about, I presume that a lot of that was expert driven, or perhaps driven by you, the modelers, to make those choices of exactly how the aggregation happened. But the fact that you're reducing the multi-dimensional impacts to a single dimension at some level, maybe just for this planning purpose, is, I think, part of the message you're having. And my question is, would you then also aggregate what you call the positive risks, which I think you mean to refer to the benefits of mining?
Opportunities, yeah.
Theoretically, you could use those to offset some of these, to move, maybe, I guess, maybe small numbers of vulnerability class is good. So you'd move up the vulnerability chain to a smaller number. If you're getting a good, output from your mine, and you're employing lots of people, and you're painting.
Yeah, you can, if you have specialized parameters that allow you a quantification and a rendering through GIS, yeah, you can absolutely assess and counterbalance in a certain way the positive risks. Here, in this accidental scenario, there were no positive risks considered because we thought in the scenario we created, tailings dam failure does not have finally positive outcomes.
Sure. Not the failure part, sure.
Yeah, but as you, yeah, actually one part that we wanted to mix, it was finally to mix the failure, the accidental risk scenario with the ordinary risk scenario, and say we prefer, let's say, a scenario in which there are one or multiple projects that if they fail, they have that, but if they don't fail, they can have those positive outcomes, etc., etc. Or another scenario in which we have a different result. So yeah, actually, we could combine those kind of events to obtain finally, to counterbalance the positive and negative outcomes of the project.
So in doing that, are you when you talk about this methodology, are you talking about a software tool that will help people do that aggregation? Or is that aggregation already sort of structured, and I just have to, let's say I wanted to apply your methodology to a different site. How labor intensive would it be? I mean, for instance, how many people worked on this project to make these aggregate maps? And would I expect to have a great deal of economy if I used your methodology in doing it in a completely new site?
Yeah, actually, if you would like, for instance, if I imagine your example, you would like to apply the same methodology to another case, for instance. But at the moment, it's a prototype of a basic step. So actually, you have to do 3 years of PhD again, and to do another stuff and to develop the methodology. Because finally, this methodology, it was me and my two supervisors that were following this project.
Okay, so that's
it's extremely time consuming and extremely, I mean, it was just us, yeah. I mean, I did the PhD.
5 years.
But yeah, but one of the main perspective of that we wanted to do during last year, then there's been the COVID problem, so we could not have internships or other contracts, is to recruit somebody to develop an automated tool to reproduce the same steps and the same codes we used at each each step of the methodology on different tools, existing tools.
Yeah, well, all plans. What is it? Humans make plans and God laughs at them.
Yeah.
You said you got one response from the miners. So you wrote the questionnaires yourselves?
Yes.
And finally, on slide 102, you said, it really looks like TMSB is best, right?
Yeah, according to how we did the assessment.
But I guess TMSA is the single. I don't understand what a single facility or a single company that makes the TMSA different from the 6 things that are in TMSB.
TMSA, it's one large-scale mining project.
Okay, so it actually 2.83 doesn't seem that much higher than 2.76. So, it's a lot easier to regulate one facility than it is to regulate 6 facilities. So would a decision maker possibly choose, TMSA simply for the simplicity of the regulatory approach? Would you think that would be a proper use of this global score assessment?
Not at this stage. I think it would be fundamental to integrate, for instance, uncertainty and sensitivity analysis into that to know the plus and the less of each score, let's say.
So how would you? So you expect that those numbers at the bottom are different? I'm sorry, they are uncertain in some way. Do you have a methodology to account for that uncertainty, or you can imagine one?
No, because it was not the main focus of the. I mean, it was something that was open to the perspective, and it will be surely integrated with the years. But during the 3 limited years of the PhD project, was not. We didn't do that. We put as a perspective a stuff that we should have included, or that would have been anyway included in the future. But it was considered as one of the limiting factors. That's for sure.
Finally, and my final question is, what's on the wall behind you? Because it looks like you have a vampire cape.
Sorry, I haven't seen it.
Very long.
It's not the same.
What is it? What does it say?
It's wait, because I don't see myself. Yeah, it's true that it seems. It's the logo of the school where we are.
Oh, this is mean.
Laboratory. It's located in University of Lorraine, and this part of the laboratory is within the geoengineering department of the École des Mines in Nancy, which is the logo. My vampire cap.
Right.
Yeah.
Merci.
You're welcome. It's true, actually. Yeah. I hope I was not like that during all the presentation. Yeah.
I did some extra drama. It was fine.
Look into my eyes.
Yeah. I don't think there are any other hands up. So if everyone's got any questions, jump in now. Otherwise, I think that'll conclude the formal talks and recording. And thank Ottone for his talk.
Thank you very much for the opportunity.